Good afternoon, dear students. So, we have completed that third chapter, that is coordinate geometry. In that, we have studied the distance between the 2 points. Then, we have discussed about the triangles, vertices, points, median. Then, we have also discussed about the section formula. And then, we have discussed about the equations of the straight in all the forms, that is y-intercept form. We have also studied the equation of circles and various curves and the lines. So next, okay, Jaswinder, very good morning. Other students also, please may mark the attendance. So today, next fourth topic, that is sequence and series, right? So today we will discuss different sequences. The main that arithmetic progression, geometric progressions, we will take questions from arithmetic sequence, right? And so sequence and series, right? So first of all, the sequence, we have used the word sequence so many times. Like if children in the school they are standing, so we are saying, okay, stand in a particular sequence, this particular pattern, right? So a set of sequence is a set of numbers, in a given order, in a given order, right? A sequence is a set of a given number in order, like we have 1 upon 2, 1 upon 4, 1 upon 8, 1 upon 16, so on, right? So here, see, there is a 2 double is 4, 4 double is 8, 8 double is 16, another maybe 1 upon 32, 1 upon 62, right? So there is a particular pattern here. So Deepak also, very good morning. I have not read your message. Deepak and Jaswinder, welcome in class. One more is there. You can write down your name in the comment box. Okay, for attendance point of view. So next we have each of these numbers is called term. Each of these number is called term of the sequence, right? Every number in the sequence is called term. And in our reference, we are naming first term, second term, third term. Like in a previous class, we have written like U1, U2, U3, U4, right? And so on, that UN or UK. Any variable UK means that is the last term. Okay. Now, what is the difference between the sequence and series? In a sequence, when we add all these, suppose we have here 1 by 2 plus 1 by 4 plus 1 by 8 plus 1 by 16, right? So on, then this is called series, right? This is called series. So series, this is in sequence, particular numbers are set of numbers in a given order, and their sum is called the series, right? Their sum is called series. Series, we are also denoting series like that sum in this format: k belongs to 1 to k belongs to, or n, you can write here numbers, right? Or simple 1 to k, or 1 to n, or 1 to k. Then here uk, this is called summation. We have discussed earlier also summation. This is a Greek sign, Greek alphabet. This is called sigma. This is called sigma. The Greek alphabet is there, right? This is a Greek alphabet, right? And this is called summation, means sum of all the terms. So really, this is the main difference between sequence and series. Series, sum of all these terms is called as the series, right? So here we have some examples. We have about sequence and series. Infinite series, finite, these are finite when we have the nth term given, then we are saying that is the finite series or sequence. And if the n is not given, then we are saying it is infinite sequence or infinite series, right? So here a finite sequence and infinite sequence. Infinite sequence, right? Infinite sequence and infinite series, right? So first I am giving you the example of a finite one. If we have, right, 1 plus x raised to power 5, right, then we can write it as 1 plus 5x plus 10x square plus 10x cube plus 5x raised to power 4 plus x raised to power 5. So here this is a finite one. Total 1, 2, 3, 4, 5, 6, 6 terms are there. So this is a finite sequence, right? And if we have this is now when we are adding, it becomes a series. If we are writing pi, if pi we are writing, that is 2 under root 3 multiplied by 1 plus minus of 1 by 3, that is plus 5, 1 by 3, then raised to power 2 plus minus 1 by 3 whole square plus 7 into 1 by 3 minus 1 by 3 raised to power, this is cube here, power is increasing, square cube raised to power 4, so on. So this is the infinite series. This is the infinite series. Here this is 1, 2, and here this is additional, I have written extra. So here it is what, plus 7 into minus 1 upon 3 raised to power 4, so on. So this sequence, so this series is infinite series, right? So switch over to now, we will start arithmetic progressions in detail. Arithmetic progressions, right? In AP we have a sequence in which terms increasing, a sequence in which the terms, in a sequence in which the terms increasing by addition of, terms increasing by addition of addition of one fixed number of one fixed amount or number, or we can say, or decreased by the subtraction of fixed amount, or decreased by a fixed amount or number is called arithmetic progression, is called arithmetic progression. For example, here if we start 5, 7, 9, 11, 13, 15, 17, so on, right? So here we, first term, we have denoted it as ui, or we are also writing it as a1 or a. So here a is what? 5. And what is the last term? Last term here is 17. 1, 7, 17, right? So here we can write that a1 or a, or even u1, whatever you are preferring, a first term, or a1, or we are writing it as u1 is equal to 5, u2, u2 the second term, that is equal to 5 plus 2, right? Here u3 the third term, that is 5 plus 2 plus 2, right? Particular pattern here again, the fourth term, that is 5 plus 2 plus 2 plus 2 plus 2, right? One more 2. In every succeeding term we are adding the fixed amount, that is 2 here. So here into in every successive, the difference between every successive terms, that is constant, that remains same. So in ap, the common difference, this fixed amount is called common difference. In an ap in an ap in an ap this fixed amount is called, this fixed amount is called common difference, is called common difference. This is called common difference. Like here we can write on, like here this first term is equal to a1 is equal to a2 is equal to a plus d. Like here u1 first term, that was 5, then u2, that is a plus d, 5 plus 2 is equal to 7, a3 we can write a plus 2d, or here that is u3 is again, that is a is 5 plus 2 into 2, so it is equal to 9. So same a4, a5, a6, a7, and even we can go with the last nth term of the ap, a plus 3d, a plus 4d, a plus 5d, and what is the seventh term? A plus 60. One is less, one number is less, so we can reduce the formula here. So same here we have the seventh term, that is u7 is equal to a plus 6d. What is the a? A is 5, d is 2, so our seventh term of this ap is 12 plus 5, that is 17, right? So we can find the general formula for the nth term of ap, right? So here, if same, suppose we have to find 10th term, a10, So A10 is equal to first term plus n minus 1 into d, right? So n minus 1 into d. A is 5, n minus 1, that is 9d. So A10 is same. If we have to find 50th term, we can write A plus 49d. In short form, we can write. If we have to find A 155 term, A plus 154 into d, right? One less. So here, please write down the general form or standard form of the nth term, that is an or un, you can write, is equal to a plus n minus 1 into d, where an is the where an is the nth term of the AP, a is the first term, n is the number, that is nth term, that n is n, and d is the common difference, right? So we will take few examples, okay, from the book, and then we will discuss the questions. So first example is find the sum of first. Okay, we have not discussed about the sum of the APs. So sum of the APs, let me discuss, and we can derive the formula also. So first example is about sum. So I have not discussed about the sum is series. Okay, what is that? If we have a sequence like A1 plus A2, A3 plus A4 plus A5, so on, last plus AN, means sum of n terms of an AP. Sum of n terms of an AP, right? Sum of n terms of an AP. So here we have the formula Sn is equal to, one is 1 by 2 a into, sorry, 1 by 2 here n, twice of a plus n minus 1 into d, right? And this can be also written as, this is also written as n by 2 into a plus l, or I should discuss what is this l here. How to come this formula? From this formula, this is nothing, n by 2, right? A, l, again l is nothing, l is n, l here, l is equal to a n, nth term. Putting the formula, previous formula, that is a plus n minus 1 into d, will get the same formula. Both are one and same, this one and this one. So here we got, that is 1 by 2 n into a plus a, 2a plus n minus 1 into d, right? So these are the formulas for the sum of n terms, right? So let's take now example. Here we have, the example is find the sum of find the sum of find the sum of first 100 term of the progression. Find the sum of first 100 term of the progression. Find the sum of 100 term of progression. First term is 1, then 1 by 4, then 1 by 2, then 1 3 by 4, and so on. So here these are in a mixed form. We can write them in, one is already 1. Here it is 4 plus 1, 5 upon 4. Then we have 4 upon 2. Sorry, it is 2 ones are 2 plus 1, that is 3 upon 2. So on. 5, sorry, 4 plus 3, 7 upon 4. So on. Right? So what is the common difference? D here is equal to, here D is 5 upon 4 minus 1. So here it is equal to, LCM is 4. So we have 1 by 4. Common difference here is 1 by 4. If you want to check, it is already given the progression here. If you want to check, we can check here like 3 by 2 minus 5 by 4. Right? So here LCM is 4. 6 minus 5, that is also 1 by 4. Next one also, that is your 7 by 4 minus of 3 by 2. So we have here 4, 7 minus 6 is equal to 1 by 4. So here there is no need to check, only from any two subsequent or succeeding terms we can find the common difference. Common difference is always equal to sum of two consequent, the difference of the succeeding term minus the preceding terms, always, right? So here this is the succeeding term, this is preceding term, this is succeeding term, this is preceding term. So always the common difference is the difference between the succeeding, every succeeding term to its preceding term, right? This is the common difference. So here we want to find the sum. We want to find the sum of first 100 term, right? So we know the formulas. S100 is equal to n by 2. N is 100 here. What is n? N is 100. First term a is 1, right? And d, the common difference, that is 1 by 4. What is the common difference? 1 by 4. So here we'll write 1 by 2, n, that is 100, multiply by 2a. 2a is 2 into 1 plus n minus 1, that is 99, into d. Common difference is 1 by 4. So here 2 ones are 2, 50 here. So sum is 50 into 2 plus 99 upon 4. So when we take the LCM here, so here the sum is 50, right? Sum is 50 here, and when we are taking the LCM, LCM is 4. So 4 twos are 8 plus 99, right? So here we can divide also, that is 2 here, and here it is 25. So the sum is 25 into, so here we can add, that is 107 upon 2. So we can write it in then in mixed fraction, right? We want to multiply. This is the sum of 100 term of an AP. Sum of 100th term, all the 100 terms, that is, if we multiply here, then it is equal to 25 sevens are 175. So 175, 17 is a carry. So 7 here, right? And 1 is the carry. 25 ones are 25. 25 plus 1, that is 26, right? Or you can check it once again, if 107 into 25, right? 5, that is 35, right? And 5 ones are 5. 2s are 14 and 2 here. So it is 5, 7, 6, 2. So it is the right one. So what is the in mixed fraction? We can write here that is 2, 2 ones are 2, 2 threes are 6, and 2 threes are 6. Sorry, 2 ones are 2, 2 threes are 6, 2 threes are 6, and yes, 2 ones are 2, right? And so it is not 2, it will be 1, 1 or 2. Or you can divide, you can keep it in the same form. Okay, sum of that is 2675 upon 2. This is sum of first 100 term of an AP, right? So let's take one more example. Or here you have to tell whether the following sequences are arithmetic or not. Okay, now it's your turn. You have to tell whether the sequence are AP or not. This is exercise question. You have to, if so, state the common difference and the seventh term, right? Here in all question number 1, it is having 7 parts. First, sorry, 5 parts. 2, 3, 4, and 5. Right? First is 27, 29, 31, 33, so on. You have to tell whether these are the arithmetic sequence or not. 1, 2, 3, 5, 1, 2, 3, 5, 8, so on. 2, 4, 2, 4, 6, 2, 4, it's not 6, it is 8 here. 8, 16. Then if you have 3, 7, 11, 15, so on. And then you have 8, 6, 4, 2. First of all, you have to tell whether they are AP or not. If they are those who are AP, you have to find their seventh term, and using the formula, you have to use the formula. So do it fast. Like first one 27, then 29, 31. So you have to tell whether it is an AP or not. So here it is the first one, that is the AP, because common difference it seems same. Okay, we will so in the first part it is an AP, and we can find the A7. Why it is an AP? Common difference here, that is 2. 27 plus 2, 29 plus 2, 31 plus 2, 33. So it is an AP. So what is A7 in this case? A7 is equal to A plus 6D. A plus 6D. D is 2. Right? Why? Because formula is AN is equal to A plus N minus 1 into D. Right? This is the formula. For all the questions for the terms of AP, we will use this formula. So here, what is this number? This number is 12. 27 plus 12. So here we have the number is 39. A7 is equal to 39. So second one here is 1, 2, 3. Then it is coming 5. Then it is coming 8. So this number is not an AP. This the sequence is not an AP, right? Because here the common difference is not same. So straight away, when the common difference is not same, that is not the arithmetic progression. Now third one, 2, 4, 8, 16. This is not also arithmetic progression, right? So here we have 3 plus 4, 7, 7 plus 4, 11, 11 plus 4, 15. So this is an AP. So this is not an AP, right? This is not an AP, right? This is an AP where A is 3. What is A? A is 3 and the common difference is 4. Common difference is 4. So what is the seventh term? Seventh term same, that is A plus 6D. What is A? A is 3, D is 4. So answer here is A7 for this question, this fourth part, that is 3 plus 24. 3 plus 24, that is 27. Whereas 8, 6, 4, 2. Here, what is the common? This is also AP because common difference is same. D here is minus 2. In this question, last one, D is same, right? Here 8, then 6, 4, 2, so on. What is A? 8, common difference, that is minus 2. So we are interested to find the seventh term. Seventh term is A plus 6D. So A here is 8, 6, D here is minus 12, sorry, minus 2. So 8 minus 12 is equal to minus of 4. So in this AP, seventh term of the AP, that will be minus of 4, right? That is minus of 4. So in the exercise, for the holidays homework, you can go through chapter number 3 and this chapter number 4, especially very first exercise of arithmetic progressions, right? So let's take some application based questions. In that we have discussed in the previous class also, like if in that case, if we have the sum of odd terms or even terms, we can add, like if we have three terms in AP, three terms in AP, we can also write them like A minus D, A and A plus D. If we have five terms, then A, A, A minus D, A, sorry, A minus 2D, A plus D, and A plus 2D. So these five terms are also in AP, right? So we can use these terms also, right? So let's take one very beautiful questions from school. In a tree plantation, that is called One Mahotsav. Okay, every class they are planting a tree. Okay, and classes are from class 1 to class 12, and every class is having three sections, right? Every class, right? In a school, we have classes from grade 1 to grade 12, right? Grade 1 to grade 12, and every class is having, and every class is having three sections. Now on tree plantation day, every class according to their every section, every section in the school, in the school plants plants the tree equal to number of their class. Like if grade 1 is there, grade 1 they are planting only one tree. Grade 2, every section they are planting two trees. Grade 3 they are planting three trees. Three trees, so on. Grade 12, every section they will plant tree individually, 12 plants each. Grade 11 they will plant 11 questions each. Okay, so question is, find the total number of trees planted by this whole school. Find total number of plants plants planted by this whole school. Whole school. So here we will frame one AP, because in the school we have every section is having every class is having three sections, grade 1 to grade 12, and then we will frame an AP and we will find the sum of the APs, right? So first, like we have grade 1, how many sections? They have three sections, and all the three sections they are planting one tree, so total number of trees are three only. Grade 2, they are also planting three trees. It's not 2 into 3, that is 6 trees. So every section they are planting two trees, and three sections are there, so 6. In the same way, third class they have three sections, then 9 plants. Fourth, they will plant 12 trees, and so on. Grade 12, grade A12, like appear saying 36, right? So on. So AP starts from 3 and 12th classes, all the three sections together they plant 36 trees. So this is an AP because common difference is of 3. Grade 1 planting 3 trees, grade 2 planting 6 trees, grade 4 planting 12 trees, grade 5 15, so on. So here we will apply the formula, sum of n terms is equal to n by 2 into a plus l, right? We will put the value here, Sn is equal to n by 2 into a plus, because here the first term that is 3 and last term that is given 36. So we will substitute the value. Total we have Sn is 12 classes. So here we have n is 12 divided by 2. A here is number of the classes, that is 12, and here we have first term is 3 and the last term is 36. 2 ones are 2, 6. Sum of all the classes, the plantation planted by the school, that is 6 into 39, right? 9 fours are 54 and 9 threes are 18. 18 plus 5. So whole school on this plantation one Mahotsav day, they will plant 200. They will plant 234 plants, right? So this is the application based. So we can frame. So we have the kth term of arithmetic progression is given by. So here we have a question, one more question from exercise. Let me write the question on the board. The kth term of arithmetic progression is given by the kth term, question number 5, the kth term of the term of an AP is given by the kth term of an AP is given by UK is equal to 14 plus 2k, right? So here two things are asked. First is write down the first three terms of the progression. First part is write three terms of the progression. First three terms. First three terms, right? And second one, they are saying calculate the sum of first 12 term of this progression. Calculate the sum of, simply I am writing sum of 12 terms. These two things is given. So how to find the first three terms? So first three terms, so here u1 is equal to 14 plus 2 into 1, that is equal to 16. So first term of the AP is 16, right? Second, second term, that is 14 plus 2 into 2. So that is 14 plus 4 is 18. So next term is 18, right? Third term, u3 is equal to 14 plus 2 into 3, right? Here it is 20, right? So what is the A? What is the first term? First term u1 is equal to 16. And what is the common difference? Common difference remains of 2. So we are interested here sum of 12 terms. This is the first three terms like 22, 23, so on. If you want to check, like you want to go with u4, u4 is 14 plus 2 into 4, that is 22. This is the first part of the answer. 16, 18, 20 and 22, right? Whereas S12 means sum of first 12 terms. That is formula we will use, that is n by 2 into twice of a plus n minus 1 into d, right? So here n is what? 12 divided by 2. A here is 2 into 16. 2 into 16 plus n minus 1. N minus 1, that is now 11. 12 minus 1 is 11. And d common difference is 2 here, right? So here 2 will get cancelled here with this one. And we have left here 12 into, that is 16 plus 11, right? 16 plus 11 is 16. 16 we has 176 into 12. 176. So here 12 into 176 multiply by 12. So 12 it is 12, 1, 14 plus 1, 15, 1, 3 and 176. So here we have 2, 1, 1 and 2. 2, 1, 1, 2. Sum of first 12 term is 2, 1, 1, 2, right? So dear students, this is all about today's class. So winter vacations, they are also going to start. So you can complete your that we have completed coordinate geometry, and this first exercise is a very simple exercise based on your arithmetic progressions. So kindly solve these questions based on arithmetic progressions, right? So with this, I am now ending today's class. Thank you very much. God bless you all. Stay safe, stay healthy, and wish you a very happy new year in advance, right? So with this, I am ending today's class.